coordinates as well as Vx and Vy, or velocity in the x and y direction, to model a simple object. So on the screen here I have a black square. That could be anything you wanted to animate, an image, etc., etc. The key is I'm representing that square as an object which has an x and a y. So right now it's got an x value of 235 and a y value of 255. That tells you where it is in the canvas. And then I've also got a Vx and a Vy value, and that stands for how much I'm moving to the right or up and down. So Vx is velocity in the x direction, and Vy is velocity in the up direction. And then I've rigged up these buttons to change the velocities. So let's say I click the right button. My velocity in the x direction is now 10 pixels per second, and the square is slowly moving to the right. If I click it a few more times, it'll move more quickly. When it hits the edge, the velocity multiplies by -1, so it went from 80 to -80, and that's how it bounces. So there it jumped. And I can also move it in the up direction. And if you watch the velocity, you'll see right now I've set 60 and -80. When it hits the edge, it's going to go from -80 to 80, and from 60 to -60. So this is a very simple way to model movement. It's pretty fun, actually. You can easily add things like gravity to this without sort of any trouble. So let me just show you how this modeling works. All right. So what I have here is, first of all, I created an object, and this is like the other code we've done. So I think I had snowflake in one of the examples. Here I just called it thingy. That's the square. And it's got an x and a y coordinate. And then I also added a Vx and a Vy, those properties. And that stands for how it's moving. When this animation started, I set them to 0. If I set it to an initial value, it would start moving as soon as it starts running. I'll put it back to 0. All right, so that's the object itself. Now the basic idea is I am asking, here, let me scroll down to the canvas animation. Here's my animate function. This is the one that runs 60 times a second. It checks if I'm being run by the browser, and if so, I call my update function with an elapsed time, so that's how many milliseconds have gone by, and then I draw the object. So 60 times a second, I'm just saying, hey, 16 milliseconds have gone by, update my object, draw my object. Update my object, draw my object. The only other thing that's in this example, you probably wouldn't want to copy this, is this output debug data, which puts the x, y, vx, and vy onto the screen to make it easy for students to understand what's happening. So, you wouldn't need that in your own code, but I thought that was kind of handy. All right, so let's go to the update. That's kind of the important thing. The draw is like any other drawing you might have. You might have a much more complex draw program if you were doing something like putting an image on and rotating it. For this example, I just put a rectangle in. So all I'm doing is putting a rectangle at x, y that is 50 by 50 and clearing the canvas. So I have a very simple draw function. But let's take a look at my update function and see how this works. This is also remarkably simple. So all I'm doing is I'm taking the x value and I'm adding Vx times elapsed over 1,000. So what y times elapsed over 1,000? I want it to move velocity x per second. So if 16 milliseconds have gone by, this would move 16 1,000ths of whatever Vx is. And the same with Vy. So, let's say that x is 10 and y is 10. Then it's going to move over the course of 10 seconds. It will move 10 pixels to the right and 10 pixels down. I added this rounding here. That's considered good practice because it's hard for the browser to animate decimal pixels. It can make some issues, but the real reason I did this was so that you wouldn't see a bunch of odd decimals making my debug output. So you wouldn't necessarily need that code. So all I did is add x and add y, and that would make it move. Then I added check edges. So if I take the check edges out, if I just comment that code out, this should update. In that case, let's say that I add 50, this is just going to go right off the screen. So my screen is 500 pixels wide, and the X is now up at 600. So I have to move it back. You can see it floated right off the screen. Here it's going to come back. Whoop. And if I move the VX to 0, I can stop it again. So there it is. So if I don't check for the edges of the screen, it bounces right off. I put that in a separate function. You could write it all in one place, but it's good practice to keep your functions kind of tidy. So what my check edges function does is it's just got a series of if statements that check the X position. So it says, hey, if my X position is greater than the canvas width, first of all, put me at the edge. So this is kind of important because it's possible to write code that will sort of make your object get stuck at the edge and bounce forever. So I don't ever let it go over the edge. It goes right to the edge. And then I multiply. This times equals means multiply by, and set it to itself multiplied by -1. So if the Vx was 80, now the Vx is -80. So that just bounces it off the canvas. Now there's some neat effects if you want to do, for example, if you want to imagine that it loses speed every time it bounces, you could do like, I'm going to multiply it by, -0.8, and then it will lose speed each time it bounces, instead of multiplying it by 1. So that's a kind of neat option you can do if you want. And I have a code for the top and code for the bottom. I will change those in a minute, but let me just show you how that would work if I multiply by -0.8. And let me speed this thing up. 140. Now it jumped down to 120, down to 96. So it's slowing down each time it bounces, which is kind of cool. That's also very cool, just to show you again how easy this VX is to use. If I wanted to put gravity into this world, all I have to do is each time we update, I can just add gravity. So gravity, what is gravity? Gravity accelerates us in a down direction, right? So if I say thingy Vy plus equals, and here I can just decide some value. So I'll say, let's say 10 pixels per second it accelerates. So I'll say 10 times elapsed over 1,000. All right, and now it's going to accelerate down. And I can still kind of launch it with my buttons, but you'll see it's kind of moving in an arc, and it looks a little janky. My computer has a lot of trouble when it's doing a screencast in these animations. The minute I stop screencasting, it'll go a lot smoother. But we can see this thing is slowly accelerating down, and again, I can make this, let me make the gravity much stronger, 10 times stronger, and you'll see now it's going to bounce, and it's going to look kind of gravity-like, right? There you go. So now I have an object that's bouncing like a ball. So it's pretty cool once you start modeling with Vx and Vy. You have a lot of very simple options. And here, if I remove gravity, I'll go back to that sort of floating screensaver you all know and love. So there you go. That's kind of the whole idea. I've got a Vx and a Vy value, and I just multiply them when they get to the edges. And the other things you might notice, this one's going through the edge when it gets to the end. That's because I didn't take into account the width of the object. Draw a rectangle draws from the top left corner. So if I wanted to take into account the width of the object, I'd have to go back into my check code, and I have to fix the right-hand side. So here this would be canvas width. I think it's 50 pixels, so I could say -50 and -50 there. And let's launch it to the right and see if that worked. Oops, sorry. Now it should bounce. Yeah, now it bounces at the edge. Like so. Cool. And I could do the same thing for the top. I mean for the bottom if I wanted it not to go through the bottom. Canvas height minus 50 and canvas height minus 50. Those are little details that you can fix up as you go, but it's a very simple concept as Vx and Vy, and it's a really nice way to model bouncing. All right, all set.